Um, so can I start?
Yes,
Oui, c'est bon.
just before we welcome everybody who's coming today. So we'll have two presentations, one about data science and machine learning, an introductory session, if you can call it like that, but very interesting
Mhm.
for sure. And the second will be about, getting some practical networking snippets with Python. So that will be the two talks we have to do. Thank you for coming. Okay, you can start.
All right. Yeah. Thank you, and thanks a lot for organizing the event. Yeah. So this will be a small intro to data sciences. I've put an S because, well, I will do a little bit of data, what we call pre-processing, and then I will jump to very basic machine learning approach. And yeah, so I quickly introduce myself. So who I am, I'm Thierry Lincoln. I am a master in computer science at from a French school called IZEP. It's based in Paris, and I've majored there in data sciences. I graduated in 2020, so that's quite recent. I had the opportunity to do an internship at a big advertising company in France called Gravity, where they had like extremely big data. Uh, we were talking about 1.2 billion records per month that were processed and analyzed. And I had the opportunity also to conduct research for 1 year at Stanford University, mainly in NLP, which is natural language processing, which is a subset of AI and machine learning. And right now, since COVID, I came back to Mauritius, and I'm launching a startup called Sakai. And I'm also doing a little bit of part-time consulting, machine learning consulting work. So directly, I will switch to actually presenting some code and Jupyter notebooks, as well as overall explanation. So that data, can you see which screen do you see right now?
Jupiter.
Oh, okay, yeah. So that works. Okay, but so well, first there's this step in data science or where you need to read data, indeed, and Python has now become one of the main language in which people perform any data science task. That's for a few reasons. There's a lot of very good data science and machine learning libraries in Python, such as sklearn. Um, there is also TensorFlow, which is a more deep learning and more advanced technique library. And also on the side of data pre-processing, there's a lot of extremely good libraries which are provided in Python. And those libraries like really set the language apart, in my opinion, compared to many other language in which you can do data science. I think one of the main, the most specialized language in which that was created for data science is R, but R really works well. But for example, if you need to connect your data science or your machine learning model to a server or provide it as an API, then sometimes you have to use a different language to perform that with R. But with Python, you can use Python with any library that you want that can perform such operations, such as Flask. So Python can be an end-to-end language in data science, and not all language can can actually claim that. So I was talking about data pre-processing and how Python had good library. And there's also for data pipelines, which is several steps of pre-processing. There's a very good library or software provided, which is called Airflow. And actually, we had a presentation at PyMug, I think three three months ago. Is that right? 3 months ago, where we had a Airflow expert that explained to us some of the concepts. And this library also is compatible with Python. So let me jump to the core subject. So data pre-processing with Panda. So when we ask like typical Pythoners to read a CSV file, CSV file is a typical file which contains data. It's like an Excel type of format, or it's CSV stands for column separated file. They will typically do it with the raw CSV library, and they will perform it that way. So this isn't necessarily bad, but for data processing and for doing some further analysis down the line, it's rather complex and it's not that handy, I would say. So really, right now in data analysis or data science, most people use a library which is called Panda to perform any data pre-processing or even reading CSV or tabular style data. So Panda is a software library written in Python programming language for data manipulation, analysis, and analysis. In particular, it offers data structure and operation for manipulating numerical table and time series. It was created in 2008, so quite recent actually. Interesting fact, just to point out, um, oh, Panda is based on NumPy, which is also another uh, data manipulation library, which is very popular, but it's not 100%. Matrix operation are based on NumPy logic. Since NumPy is already very efficient and use really fast C Python code to perform such calculation, but all the data structure in Panda are really Panda specific. So in practice, throughout this little example, we'll try to analyze one of the famous dataset that we have is called the Titanic passenger dataset. uh, to make to make the case here. So with this line of code, you can see that it's really easy to actually read a dataset with Panda. Just do panda.read CSV. Well, if the dataset is a CSV, just do pd.read CSV, and then it will actually read the dataset. And so if you compare that to what we saw above, that is already much shorter. And you can perform the following command, which is df.head, to see a snippet of the current dataset. So I will go through it just rapidly here. So for instance, here you have a passenger ID, which was the ID of the passenger for the Titanic. You have a column class if the passengers survive or not. You have the passenger class, first class, third class, second class. You have the sex, the age, and many other parameters such as how much did they pay or the exact cabin number. So I will showcase some basic data cleaning and pre-processing right here. Let's say here you can see in the dataset, let me reload that just a sec, that we have a column called name. So let's say we want to be GDPR or well, this is badly written, but GDPR or Data Protection Act conscious. Thus, we want to drop that name column. So it's really easy in Panda to do it. Just do df.drop and the column name on the axis 1. Axis 1 is the column axis and axis 0 is the row axis. So we just do that, and then as you can see, directly the column is dropped. And to select one column with Panda, you just do df and you put the name of the column. And here I'm doing the head command just to showcase a snippet. Again, really simple to select a column. There's an alternative method where you can do df.lock, like location. You don't, and this takes as parameter any row that you may want to see and the column name that you want to see also, and then head again, and you see that it's equivalent to what we saw up there. Again, to select multiple column, that's also possible. You just pass a list of the column names and it will select the columns. And you can also do conditional selection, such as here you can see I've selected age under 24. And again, really, really simple to do such selection or manipulation. Notice here that we have some spaces in the ticket numbers. Right here, I don't think that this dataset, the ticket numbers are quite important, but I've selected that as an example of typical data manipulation or data cleaning that you may want to do. And so let's see that we don't like those spaces here. Usually, well, in programmation, we don't like spaces anywhere. So let's say that we want to trim those spaces. So first, we can create a function that will actually trim the space in any given string. So here I've wrote this basic function. I mean, I wrote it very rapidly, but you understand the concept. I did a little if to check if the type of this was actually a string. If not, I raise an exception. And if it's actually a string, then I just do string.replace and I replace the space with nothing. And how can I apply this function to any given row in the dataset? I simply do df, I select the column ticket, which is the column of interest. And then I do apply. And in this apply, I do a quick lambda function. I don't know if you are familiar with lambda function in Python, but it's a quick way to write any given function. And then, so the lambda function takes a parameter x. The parameter x will be passed via this apply function. And then I apply my trim function on this x variable. And then I simply do dot head. And as you can see here, all the columns, there's no more spaces in the ticket section. So, but that is just an example. If I wanted to add a function that would add +1 to every given line here, I can code this function. Actually, I can maybe do it live. It will take probably 2 seconds. I take a function that will take a number as input, and then let's say I don't check for type because I'm lazy, and then I just do number +1, let's say, and then I can apply this similarly to the class function, let's say, and then it will apply 1 to all the actual lines. And an easier way to do that would be in Python, if you just do with Panda, you can also do, I think, df, and then you enter the column name, and then you can directly do the operation like this. Let me see if it allows me. You see here directly it adds 3 + 1, and yeah. So I can also multiply the column by 2 really easily. So actually, you might find all of these quite basic and not that interesting, but trust me, if you would like to do this with a simple CSV import, it will be much more difficult and a lot slower. And so, but Panda doesn't limit to data pre-processing or data cleaning. You can do some basic data analysis with it as well. You have this very handy command, which is df.describe, that would actually do the count, the mean, standard deviation, min max of any given numerical columns, you can see that here, well, passenger ID is not a numerical column, so it doesn't make any sense. But if we analyze, for example, the mean age, you can see that the mean age was 29.69. And the variance of that number, the standard deviation is 14. So it's 29.69 plus or minus 14 years of age. You can also do some group by operation. Let's see, for example, how many died in the male group. We see that a lot of them died in the male group. So I group by survive and sex. And we can see here that, okay. So can you still hear me right now? Yep. So you can see that, for example, a lot more females survive. And so that's a really handy way to perform those group by, which is similar to what you can find in SQL or any given database query language. And with Panda, you can really quickly, easily plot graphs, but just do dot plot and then select the type of plot that you want. You can even do really easily histogram. So that makes it really, really fast to do any given graphs, plots, data pre-processing, data analysis. So it's pretty handy. And so let's say you have I just want to finish this data pre-processing session, and then I will switch to machine learning. Let's say you have, and I want to point out this more advanced problem about memory. So anyone know that we are in this big data era, and often I find myself working with sometimes gigabyte size data set. And so you will imagine that those types of data set often cannot be read directly and cannot be put into RAM completely. So no later than 2 days before, like I think it was on Thursday, a friend sent me that error and said unable to allocate 208 megabytes for an array with 2 million rows, and that's a typical error. And actually, this size, you would say, well, that's not much actually. If you have an 8 gigabyte, if you have an 8 gigabyte RAM RAM in your computer, that should be fine. But well, that depends on the data type that you have within the dataset and how Panda reads it, how it optimizes the way it stores the column so that you can read it fast. So even if you have 16, let's say you have 16 GB of RAM, with 16 GB of RAM, usually it's difficult to read even a 1 gigabyte CSV. And trust me, a 1 gigabyte CSV is a lot and a lot of rows, like millions. Well, it depends on your data type, but if you have very long strings, for example, in the dataset, well, indeed, even with fewer rows, you can get a out of memory error. So 2 ways to solve that. There is this way where you can use what we call Python generators. That Python generators, instead of reading the complete dataset, it will read a chunk of the dataset, and then you will be able to use you will be able to issue like a next command that will read the next chunk of the dataset. And so in Panda, you have a really convenient way in doing that. Is you just do pd.read CSV, and then you add a chunk size of the row number that you want, and then it will read by chunk size of three blocks of three in the dataset. And so if I already ran that command, and as you can see, now it's reading this dataset 3 rows by 3 rows. So it actually, here it can't print that, so it jumps line, but this is the next read. And so since I printed, it's queuing it here. So that's one way, and it's a convenient way because in machine learning overall, you don't necessarily need to enter the complete data set, and you don't need necessarily to train on the complete data set directly, right? You can train on a chunk of the data set and then continue to train on another chunk, and then it goes on and on. So there's another way, and it's a library which we call Dask. And Dask is a library that we built on top of Panda, basically, that allow you to load. It's a bit similar than chunk size, but it allows you to load little Pandas dataset. So it allows you to split the big dataset into smaller Panda dataset. And what's interesting is that you can even distribute that dataset on multiple machines. Let's say if you have a server, and it works quite the same as Panda. So you do import dask.dataframe as dd here, and then you do dd.readcsv, and as usual, you have all the basic commands. And with that method, you can directly read very huge dataset, and Dask would handle whatever is required to perform the operation while keeping without actually giving you an out of memory error. So it might be slower, and Dask also process data by using actually a multi-core or multi-threaded approach. So it might make your processing faster as well. So that was a quick introduction about pre-processing with Panda. So far, do you have any question or any suggestion?
I have a question.
Sorry,
Okay.
wait just a sec. I can't see the names.
Maybe I
Let me
just
no, actually, I can't see the name because, well, Zoom hides I can't see the full
Okay.
segment. Okay, yeah,
Okay,
just ask.
it's Mr. Rengen.
Okay, yeah.
So how do you link your data to, let's right now, so far what you have shown us is read from files, and you have used a generator to like process huge amount of data. But normally you would not put your data in a file, you put it in a data lake, like Hadoop, in a Hadoop. So how would you connect your Panda tables data lake?
Yeah, so there's actually, I think, extension to perform that. So Panda connect to database, and so yeah, I think so Panda will simply create a connection, and then it would pull the necessary amount of data into memory from the database. And so instead of using read CSV, it's simply like read SQL. And well, I think there's packages provided for most databases, but usually, well, it depends if you do very complex data pipelines. But usually, most people download the data as CSV and train offline, because you don't that often train models again. But some people, indeed, in some cases, if you need to set up a complete data pipeline, as we call it, that includes uh, some monthly or weekly model refresh, as we say, or if you want to constantly train your AI model, then you simply directly connect it to the database, and then you pull the data, you train, you perform some data manipulation, and then you you can use the same library without much problem. You just have to download all the connectors necessary. And I don't know if there's a table that actually table of all Panda SQL connectors. No, I don't. I don't think. Uh, I don't have this. I may find this table where you have all the database that you want, but
So
yeah.
the reason why I'm asking that is that why would somebody use Panda when we have BI tools for database?
Sorry, I didn't.
Uh, Let me repeat. Why would somebody, we have a database of data for your data lake. Let's say you're using the database as a data lake, which you will not normally do, but let's say it's like this. Why would somebody use Panda instead of using business BI tools
Mm-hmm.
instead of Panda? So why would somebody go for Panda instead of BI tools, which are like building cubes and all that kind of stuff?
Yeah. Or even SQL, basic SQL.
SQL, yes.
Like with SQL, you can also do like group by and do some min max.
Exactly.
You
So
can
why
do
would somebody trade one for the other?
yeah. So I think two reasons. For instance, I am working right now on a data mission. I'm doing some consulting work, and some let's say BI tool. I'm using Power BI. You have this data manipulation language, which is called DAX, DAX, and I found that for some data operation, it's not necessarily that convenient. And so what I do is, instead of processing the data with Power BI, I process it with Panda, and then I re-upload those process column to the database, and then I rate those with Power BI. And it's for me it's easier because I'm much more used to Python as a language overall, and I would say that Python had much more flexibility in the type of data manipulation that you can do. Um, yeah, let's say so I will jump to the machine learning section, but let's say if you add a column of prediction here, let's say I add a column of predicted death, then in Python I can train an AI model that will try to predict if the person is dead or not. Let's say we didn't add this column and we want to predict if the person was dead or not. I can add I can train an AI model, and the model in Python can do the prediction and add it as a column here or push that column to the database. So right now in Power BI, I think you can do that, but it's less convenient. Maybe I answered your question, but yeah, if in a particular situation it's easier to do it directly with Power BI, or you surely you can do it with Power BI.
Yes, because I've tried to push for the equivalent of Panda. I was not trying to push for Panda, I was trying to push for Spark, which does the same thing. But they say they already have BI tools, so it can be Power BI or whatever. So they will
Mm,
tell you why would you not use those BI tools, which has been doing that kind of job for decades, not even years, decades.
mm,
They have been using that
yeah.
and they have the expertise in that. So why would they trade one for the other? And putting AI on the side because not many companies will go for AI. Not many people will invest in AI, especially here in Mauritius.
Mm-hmm.
So my question is, what will be the use case of Panda except apart from AI?
Um, well, like I think it's many people use it just because uh, it's simple, as you can see. Uh, it works well in Python, and since Python is now the almost by default language for doing any data related work, um, but apart from AI right now, I don't think it's the I don't think it's the best tool to do data pre-processing. But Python as a language is a very good language to do any data pre-processing.
The same
Yeah,
can be said for Spark and the Spark ecosystem. And just
yeah,
looking over the
yeah,
Spark ecosystem, but
and
it works on Python and Java and so forth. And
yeah,
Databricks,
indeed.
because correct me if I'm wrong, you cannot do much parallel processing with distributed processing with Panda.
Mm-hmm. Yeah, you are
Correct me if I'm
absolutely
wrong.
right. Yeah, you're absolutely right.
So if I have
It's
a big data set, like I mean a huge one, a
mm-hmm.
Panda script is written in Python, and Python is not known for its speed. It's not known for that. Uh, it can take days for a processor. Somebody uses Spark, it can take like hours. So you're in a
Yeah,
chalk and cheese situation.
yeah. But I think for beginners that
Okay.
try to learn machine learning and uh, or try to start doing some data analysis, I think it's it's easier, and therefore and then further down the line when they become like much more advanced data engineer, then they can try to learn Spark and do some very distributed data pre-processing work. Yeah, indeed. So yeah, I think it just depends on where to start, maybe. And but indeed, like most data engineering pipelines, advanced one with huge scale data sets are with more advanced tools such as Spark.
Well, if I might add something, maybe Pandas was not meant for data pre-processing. It's more for data analysis, data manipulation.
Hmm. Yeah, also. So actually, in the beginning here, we did mostly only data like manipulation, right? Um, and also, well, Python is used so much in science overall with SciPy library, NumPy. Uh, I mean, most research when they perform statistical analysis. Sometimes they use R, sometimes they use MATLAB, but often they use Python. And when they use Python, they usually use Panda. So, but maybe, yeah, maybe let me jump to the other subject because otherwise I will run out of time. And I would try to be quite brief on this one. So the material isn't completely finished, uh, but I will try to speed up. And so machine learning basically it's a subfield of artificial intelligence, quote unquote. Artificial intelligence can be defined as an ensemble of theories and methods that allow machine to perform a human-alike task. And machine learning is a process or a method that allow or machine learning can be also algorithm that allow a piece of code to learn and adapt without implicit instruction, normally using data, but using label data, but that's not always the case. And uh, actually, deep learning is a subset of machine learning, and deep learning is everything about neural networks and all the fancy stuff that we hear about most recently. So I always like to put that little schematic just so that people really understand what are we talking about here. And so some disclaimers here. Some people like to introduce machine learning by using linear regression. So what is linear regression? It's when you have x, y, uh, when you have, let's say, uh, some data on the x-axis, and you have data on y-axis. So it's what we call two-dimensional data. You try to predict x, you try to predict y, sorry, as a function of x. So if I just type linear regression, you will quickly understand. Uh, when you basically try to fit a line like this is simply linear regression. And so many courses in AI introduce machine learning by using linear regression. And I fully understand why they do this. But I chose to do it differently here. And I hope that this way works too. I'm also experimenting a little bit of stuff. And so if we jump back to the previous example about the Titanic, uh, let's say, as I told just before, we would like to predict who died or not based on some characteristics. Let's say age, sex, cabin class, uh, what, whatever you want, just name it. So I understand that this is creepy, but trust me, this will be memorable because I think most data scientists in the world actually saw an example with this Titanic dataset. It's so popular. So, question, and maybe I would like the audience to speak up a little bit quite briefly, is if you were to code a Python code manually to try to predict which person survived or not, how would you do it based on the data that we saw before? If someone has an idea, oh, actually, I was supposed to hide the code below, but okay. Well, with Zoom, it's more difficult to get answers, like to do question and answer. But if we calculate all what we call conditional probability of all the different what we call feature, namely age, sex, and that we organize this as what impacts the most, who died or not, and we rank what impact the most, what which people died or not, we we can calculate all the probability and says, well, people over 45 died less, or people less than 45 died less, and people with sex female died less. And if you rank all those features or dimensions according to how much they impact what how much they impact the end result, which is if the people died or not, you can start doing some conditional algorithm that takes those as parameter. And here I just demonstrated that I created a super AI model that takes as parameter age and sex. And let's say I calculated all the probabilities and find out that people over 45 with sex female had 20% chance of dying. So then my function just take that as parameter and then return uh, the number. And if the sex is male or over, then there's 45% chance of dying, let's say. So in that example, I've performed all the calculation before, and I wrote this little algorithm. And this actually can be represented as what we call the decision tree. So here I come to actually how I want to introduce machine learning, because I think it's much more suited to the software engineering or programming logic. So this can be represented as a decision tree. Let's say age over 45, yes, no. If it's yes, then what's the sex? If the sex is female, yes, then the probability is 20% chance of dying. So, and then as we feed in new data, we can say, well, was the person over 45? Yes. Then if the person was a female, then there's probably 20% chance that this person would die. So I made my prediction. So now that we have our super AI model, I would like to point out what are the limitations of such approach. In this, indeed, this is not automatic. So the machine didn't learn anything. We coded all of this by hand. We calculated the probability by hand, and we also ranked, as we say, those feature by importance also by hand. In that case, uh, I said that age is more important than sex, and but actually I think it's the reverse in reality. So all of this was done by hand, and this is indeed not machine learning. If the data that I base my probability on changed, then I have to calculate everything again manually, and I also have to code everything in manually. And let's say if you have n features, age, sex, cabin class, whatever, you have to the power of n probabilities to calculate. So that's a lot. And as I pointed out, see you in another life. So that are the basic limitation. But so, and here, excuse me, because I haven't had a chance to finish my material. But so there's a more automated way to actually calculate all those probability and rank those features and actually build this decision tree. And so I won't get most in the theory of that because I haven't had the time to write that material down. But what you can remember is the algorithm, what he will do is in case of uh, in case of categorical prediction, let's say if you want to predict if the user died or not, at each step, what we would do is we will take, let's say, the feature age, and we will see if that feature, we will see if a split of that feature actually separate two categories really well. And if it separates the two categories really well, then we'll put that feature on top of this decision tree. And we will also try to assess what um, type of data we'll put here in order to split that data set really well. And so we'll do that at first step, and then we'll jump to another row, and then we'll do that again. We might still include age at the second step. Let's say if there's a second probability, let's say then age over 45, but also between 45 and 64, then we also add the feature age at the second step. And we go on and on and on. And so I didn't get really into theory in here, but you can get a glimpse of how we can automate such process. And just what I'm going to demonstrate here is basically how to do a decision tree like this in Python. So it's really easy again, because we have very nice library in Python. So first, you will notice that in the dataset before, the column sex was labeled as string. So it was F for female and M for male. So you have, but actually the model to train it, it doesn't really like having categorical type of features with as strings, so you can directly encode them. So with that function, and then what I just did is I splitted the dataset in train. I took 80% of the dataset and I declared that this was a trained dataset, and then I took 20% of it and I declared it as a test dataset, and then I split the dataset. And then I isolated a few features in here, just age and sex as the two features that I illustrated before. But I can also take more features. And what I want to try to learn from is who survive or not. And simply by doing classifier.fit here, it's training an actual decision tree classifier for me. And then with those line of code, I can plot it. And as you can see before, I have this tree where I have much more leaves. It's much more granulated in here, where I split it through the process that I described. And now I can use that model with new data to try to predict if the person was actually dead or not. So I already took 1 hour in here, so I won't explain that much more. But so here you can see that we already built something that learn from data automatically and try to predict something. And so this is really basic machine learning, but it avoided us the constraint of writing it ourselves by hand. But just a little funny note in here is that when you hear many companies say, oh, we are like building super advanced AI model that performs X and Y and Z, and they are really smart. Often what they do right now is that they do if and else like this. Trust me, that's very common. And that was done like 60 years ago when like at the early age of computers. So well, but so limitation of that method is that decision trees tend to have a specific behavior that in machine learning we called overfitting. So we say that decision trees are prone to overfitting. So what overfitting is that, let's say if you have 150 data point in your data set, then you can do a split in here for each and every data point. But so what that will result in is that, let's say if we had, this was the survived class and this was the dead class, then the system would have picked little what we call outliers, and thus by doing so may have picked some what we call false positive or false negative, and thus the model will be less able to predict future death. Let's say if we isolate 80% of the dataset for training and 20% for testing, then you will see that the precision on training is really high, but the precision, or as we say, accuracy uh, on testing would be quite low, because you will have a lot of outliers that would get picked up. So that's a limitation of decision trees overall. They are usually prone to overfitting. There's a mechanism to limit that overfitting, such as providing a limited amount of leaves in the actual tree, or to limit the number of split that happens. But even with that, decision trees are prone to overfitting. And also, what I want to point out is that since these are conditional splits. Often what you would see is that uh, decision trees doesn't really actually fit, quote unquote, curved space really well. So what that means is that if we have, let's say if that, as you can see here, that isolation of who's dead or not is not, is rightly, it's curved. And so in order to uh, take that into account with a decision tree, usually the decision tree will actually draw boxes between the data points. And so it won't necessarily draw a curve like this. It will draw, actually, no one can see my mouse in here, so I'm explaining uh, not in
We,
the
we, we,
Yeah, we
we can
see
see
it.
your mouse.
okay, okay, thanks. So it will simply draw a box around here. Maybe it will cut like this. And so by doing that, it would take some outliers. And if you do too much, if there's too much leaves in the tree, then it will try to, like so, isolate really tiny data points. And so that's why I said that decision tree doesn't uh, work that well with curved spaces. And that's, here is a 2D data set, or it's a 2D representation. But so in, as you can imagine, or if you did some classic linear algebra, you can work in 300 dimensional space where you have 300 different features, age, sex, type of house, name it. And so those spaces are also curved, but in 300 dimensional. So usually what we say is that decision tree draw hyperboxes, or they draw boxes, and they do not fit very well curved spaces. So in order to make decision tree work much better, oh, now I have my let me just, I have my mouse in here. So in order to make decision tree work much better, so maybe I will take the question at the end, because now I'm running a bit out of time and I don't want to let Abdul Rahman out of time. So I will take the question at the end. Make sure you write them down. So in order to make that works much better, actually, uh, one guy proposed a method which is called random forest. And what basically random forest is what we call an ensemble method, or ensemble method, in which you you create different estimators. So in our case, you create different decision trees, and for, and then you take as prediction at the end an ensemble of decision trees, or an ensemble of prediction, in order to perform the final prediction. And so just to be clear, that method of ensemble is not limited to decision trees. You can do this with any machine learning model, but that method is most well known, I think, with random forest. And so I encourage you also to read the original paper about random forest, which was issued in 2001 by Mr. Brayman, I think from University of Berkeley, if I'm not wrong. And so, and actually what random forests do is that it limits overfitting that we have with decision tree, because you average result from a lot of them. So I don't want to go much further on random forest, but what I want you to embrace are two key concepts. Imagine that here you build an ensemble of trees like this in order to predict, to do a final prediction. So the first tree try to predict if the user is dead or not. So the tree will say dead. The second tree will say dead, and maybe the third tree will say alive. And so here, if you have three trees, then you can see that you will take the prediction dead as the final prediction in the basis of a score on 2 to 1. So dead 1. But so one of the problem of any given ensemble method, and especially random forest, is that if those trees here resemble themselves, meaning that let's take the worst case scenario where this tree will be identical to this tree and will be identical to this tree, then you will do the average of the exact same tree, and therefore you won't have any advantage of computing all of these predictions, because the average of all these three will be equivalent to a single tree. So in order to solve that problem and make it so that the trees are different, so you will see that in the Breman paper, uh, Breman introduced two concepts, which is called bagging and random feature selection. And within those two concepts, Breman insists that first, the tree should be really, the strength, sorry, of the tree should be really high, meaning that any given tree should make a good prediction. But at the same time, the correlation between tree should be really low, meaning that a tree compared to another should not, the correlation should be low, and therefore those trees should not resemble themselves. And so in order to do that, there's two methods. The first method is called bagging. And so I wanted to add additional material in here, but I ran out of time actually, because last week was I was too busy. But bagging is simply, let's say you have this Titanic dataset. So let me just do df.head. Let me take that. Let's say that at each step, you take a sample of data. You take a data sample. So in this data set, we have 880 rows. Sorry, we have 714 rows. So I don't know who is right here, but we have a amount of rows. And so for each tree, basically what we can do is that we can sample a number of lines in this data set. We then train one tree on this amount of line, and usually we sample with replacement, meaning that we can even sample some lines twice. And so if you have done what like sampling theories or probabilistic theories, probabilistic sampling theories, sorry, in math or at school, you can easily see that this, first of all, is a Bernoulli, it's a Bernoulli test, I think. And this gives you an average amount of 63.2 single sample when you take all the data set as a possible sample. So let's say if you want to sample within all the data set and you sample with replacement, then 63% of all within the data set, 63% of the sample will be single and the rest will be duplicates. So meaning they will be sampled twice. So for each tree, you perform that sample. And so therefore, each tree will be trained on a slightly different data set, thus making each tree a little different one to each other. And so that's the bagging method. And also there's another mechanism that allows you to do that is random feature selection. So this principle is as follow. So when you create every single node of the trees, you have a certain amount of features that you can consider. You can consider, let's say, the age, the sex, the cabin class. But if you do a random feature selection, that means that at each step, you create what we call a subspace of feature, meaning that instead of considering all the features, you consider mostly maybe only age and sex, and you discard cabin class. And then at the next step, you do the same. Maybe you exclude age. And that means that also the trees will be a little different. And so it's the addition of all those different trees that will output a final prediction. And usually, since you did averages on multiple trees, you have a much more robust model. And also averages of box like this, if you perform many averages and that smoothen out those boxes and actually embrace curvature space much better. And so that Jupyter notebook actually will be completed, and I will actually write the code after that presentation. I will also share those code on my GitHub, and maybe Abdul Rahman will also share that on the PyMug event, or PyMug GitHub, sorry. But so, and actually myself, whenever I have any data set in which I want to perform any kind of prediction whatsoever, usually a best practice right now is trying to start with, let's say, linear regression, and then quite rapidly we take random forest as a baseline to see whether any other more advanced method that you will take would perform better than random forest. And random forest, there's this famous quote from I think an engineer from Google in data science or whatnot, that said that he always start any machine learning or project by trying to apply a random forest. So that's one basic method that you should always consider. And actually, maybe in another course, we can do random forests deep down, and we can also do decision tree deep down to see exactly how it works. But that would take a lot longer. I hope that you still understood a little bit what I was talking about. And yeah. Any questions about all this presentation in here?
I have a question. So if you had to compare random forest to linear regression, which is better, or can they even be compared to say, okay, one is better than the other, or are they just different?
So I would say that, sorry, if I had to compare linear regression and random forest, yes. So, I mean, they can compare because first, what I didn't say, or I think I said it, but in machine learning, you have usually two types of prediction. Usually, either you predict categorical data, let's say categorical data such as if a person died or not, and you can also predict linear data, let's say the price of a house based on how much square meter is the house. And so linear regression is a method that is suited for mostly what we call um, linear data, but actually the equivalent of uh, categorical prediction for linear regression is called logistic regression. And so this one is also the same, but you simply want to isolate, let's say, two classes. Let's say this class was died and this class is uh, dead. You will try to fit a model that look like this. It's called the sigmoid type model. But so random forest can perform both linear type of prediction and can perform also categorical um, prediction. And so in that way, I think they both can compare, but the underlying method is way different. The method to train a model is very different. But usually, if I had to rank, I would say that linear regression is really the basic. Linear or logistic regression is the basic. It's as basic as a decision tree. And random forest with that ensemble method is a bit more advanced and like 90, I think I would say 80% of the time would give better result than a simple linear or logistic regression. Does that answer a little bit the question? I know the
Yes,
answer was
definitely.
lengthy.
Definitely. No, no. Okay, thanks.
Any other questions?
Hi, Thierry. This is Vic.
Yeah.
This is a fantastic presentation. So thanks for putting the time into this. In terms of random forests, I just had a quick question. How do you think random forests deal with multicollinearity?
Sorry, multiple collinearity.
Multicollinearity, yes.
Yeah, so that means that the columns are correlated between
Yeah.
each other.
Yeah.
Yeah, so actually, so the question, just to make it in simpler terms, let's say if we had this column that is exactly the same one as this column, we would say that the correlation between the two columns is quite high. And so therefore, that means that we have a higher chance of getting quote unquote correlated trees. So actually I've already dealt myself with data set which have a lot of correlated columns. And so there's multiple ways to handle that. So first of all, actually random forest does not handle that pretty well, I would say. So there's several methods. First, that random feature selection method, you should definitely turn it on, because that means that some of the correlated columns may not get considered twice within those trees. So that should be turned on. Sometime in the data processing, you remove the correlated column. You do a cross correlation between all the features, and then you can just simply delete some of the correlated column, especially if they are extremely correlated, which happens. And then I would also say I think I had performed some more. I have performed some more methods to handle correlation between columns, but I can't remember them. But yeah, so basically we try to identify correlated columns. We try to erase them. You definitely want to turn on random feature selection. And that will avoid trees being correlated one to each other. But still, if you are very correlated response, it will happen more, and you will have definitely a little more correlated trees, which will render the performance of random forest lower compared to some other methods. I'm not sure about other method. Anyone in the crowd having ideas about other methods to handle correlation?
I think your answer is not too far from what I was looking for. You definitely need to read a bit more on this, and I think that's the power of these model, random forest, XGBoost, LightGBM, etc. The amount of time that you take into pre-processing your data, especially when you have large data set, if you're using logistic regression, etc., is quite tedious. And using these methods, it actually doesn't care much if you have missing data, if you have correlated features, etc. It doesn't affect your predictive power as such. But if you're looking at interpretability, then that's another thing. Then maybe you need to look into that. That's my take on it. So.
And actually, predictability, well, it's, you can do feature prediction with random forest, but that's another topic completely, because I spent at least 1 month trying to study that a little bit, and there's a lot of caveats with random forest trying to predict which feature are important. But yeah, and actually, I had this task when I was doing my internship at Gravity, where I had to predict 40 million rows of cookie internet data that were issued by 60 million active tracking cookie. And I had to predict what was the age and the sex of those people based on their uh, history, online history. And so I actually did that as a R&D project, and actually it was quite successful, because on some of the population we had over 80% accuracy, and that was audited by a separate entity, not us. So it was quite precise, and actually random forest was really good. It was performing really well, especially because there was a lot of missing values, and I could not at all get better performance with any other method. Maybe there was some very extensive method that I didn't try to use, but I've used neural networks. I've used, well, logistic regression indeed. I've used XGBoost. I've used many other assembly methods. And I could not get better result. And I think it is because there was so much missing values that random forest was the one handling those the best. But maybe I'm wrong. I don't know. But well, and actually that model actually uh, um, is still running today, and it's still being trained and updated, not by me but by somebody else. And that model brings to the company around 3,000 euro per month. Uh, that's directly. So a typical use case where AI can work. Well, in advertising, we know that AI works, but just to illustrate, and especially random forest, even though it's not like the it was created in 2001 and it's not like the most advanced method in the world, it still works. It still works in industry, and so it should be considered. And so many people right now, they learn deep learning and neural network, and they don't bother to learn classical machine learning methods, and therefore they build they use elephants to crush. I think in French is utiliser des éléphants pour écraser les mouches. Yeah, they use elephants to crush bugs. So yeah, I will end on that note maybe. And if you have more questions, you can just send me via email, or you can directly send me a message via LinkedIn. I just sharing my LinkedIn page here, as you can see here. Oh, no, this is not my LinkedIn, but you have my email here, and LinkedIn, basically it's that one. And anyway, yeah, I would put that in the Zoom message.
You have it on your second slide, your LinkedIn.
True. Yeah. Yeah. So if anyone can, if someone wants to take it, and also since I'm launching a startup, you can email me if you want to do an internship, if you are looking to be part of a nice, true machine learning project in Mauritius. And yeah, that's it.
Okay, thank you very much
I
for
was very
your.
lengthy. I'm sorry, Abdul Rahman.
No, it was. I think the machine learning part was interesting. Maybe yes, it was. Maybe more on that. Like it was really interesting. And we also thank Mr. Dimlai to be for being present today. It's a great honor for us to have you here. Last time I checked, Mr. Dimlai was a data scientist at the MCB. So, well, uh, thank you for honoring our meetup with your presence. It's one of the because it's particularly relevant because if there are some institutions that can really maybe experiment with Python in production to a somewhat high level, it would be currently the MCB because the other financial institutions they are making progress but somewhat slower. So
Thank you, Abdul. I decided to join today. I thought the topic was very interesting. Something that I'm very familiar with. So thanks for putting that together. So.
that's fine. And maybe if you or anybody else want to present something, so anytime feel free. So now we move on to our second presentation. So okay, so our second presentation. So it's about. Let me share my screen. Okay. Can you see my screen?
Yeah.
Okay. So normally when I do presentations, the first thing people actually look is at the gray uh, looking appearance of my desktop, but obviously it's not Windows XP as I will not be running all those softwares. I just stripped out my Windows of appearance effects. So okay, that's one thing. And for today, we have something about the sockets. Like I decided to have a vote this time for my talk, and this topic came out with the most votes, so I decided to do it. And I think the reason we managed to fish out Mr. Rengen for our meetup today was maybe because of networking. I have a guess. And anyways, Mr. Rengen, so feel free to comment on the parts because this is meant this presentation is meant for people to get into sockets programming and does not go into much details about really about theory, about what better methods are out there or better third-party libraries. In these examples, I'm just using the bare standard uh, library modules. So where is the chat? Mm, okay, so whatever I'm going to present, so I just put it over there. But in the assistance, I think pretty much everybody has had a brush with sockets programming, but well, maybe it's about we can put it in the sense of maybe about maybe teaching sockets programming, like what are some efficient ways to teach sockets programming, because obviously our assistants today is not going to kind of learn it from scratch. Well, let me go into full screen. So can you, yeah, well, I guess it's still okay. So, okay, that's a bit about our user group. That you can, we have some kind of nice overview over there, the MSCC blog, so you can look it out. About me, I'm a Python developer for my own account. And these days I do a lot of web programming, if you can call it like that. Okay, and okay. So normally when people start with socket programming, the first thing that they do is maybe fetching some address, um, something like that, something simple but not something very interesting. But actually, my first, myself, I was very interested into Java. But when I switched to Python, it was because of IRC. I wanted to code an IRC bot. And well, when I look at the Java codes for an IRC bot, like before I even wrote my own logic, I had to write somewhat, not extensive, but a lot of boilerplate codes. So I thought that maybe there are simpler ways to do that, and I stumbled onto Python, and that's how I got into Python, and I'm still with it today. So normally normally what I'm going to present is on the first slides. It's actually a project I have on GitHub. It's an IRC bot. Okay, how many of you are familiar with IRC? Maybe you can just speak, maybe.
I am not that I have not done my in 15 years,
Who is that?
and then
Oh, Mr. Rengen. By the way, Mr. Rengen, your volume is a bit low. I don't know why. Well, that's okay. Yes, normally this bot nowadays, okay, you have some nice plugins. Okay, it's you have some plugins, and you can even play Monopoly with a bot. It's got some really nice a nice plugin ecosystem and a very simple way of doing plugins. But in the slides, I'm just presenting you the what the first few lines look like. Well, the first step was to just instantiate socket connecting connecting to the server, then to the port, and then receiving whatever was being sent, and uh, and then according to the IOC protocol, you can send some you can set your nickname, etc. And then what you have to do is you have to keep your bot alive. You have to keep your bot alive. That means you have to know when the server sends has ping in the message. So you send back a phone. So that's it. That's the basics of an IOC bot. You just basically these lines do the magic, which is something very simple. And though the bots is just identifying, keeping your bot alive, etc. But it's kind of the most simple one, but also interesting part of interesting project you can do with sockets. And normally, if you okay, okay if you run the bot. Normally, the bot would connect, but it's a very simple demo to get started. So you will get all the raw message that the server sends. And if you go into a client called Kiwi, well, zoom it kind of gets into my way. Kiwi iOS client. Okay, I'm connected to Freenode. Normally, for this demo, I'm using Freenode. So, okay, so the same things that you get here. So you get it in the bot. But and then if you go into the client, you can see that the bot is here, and then you can see some message. You can send in the some message, and then you can get it in the bot. That was kind of version one of the bot, but it's I feel it's the most interesting sockets programming project, like, to begin with, because it's very simple. It's you can be as creative as you want. Normally the bot is more polished nowadays, but in the repository you can get what somewhat how version one looked like. So that's it. Well, I was normally normally the web protocol, it abstracts really sockets programming. You don't have to type in numbers to get to a web page, but just maybe a simple fact that the default port for web communication is port 80. Like, you don't have to specify it. But if ever you use another port, so you have to specify it in the URL. And normally this is something interesting. Normally here you will see socket dot or ECV socket dot receive. So when the socket receives 0 bytes, okay, that means that for example, if we're connecting to a server, that means that we won't get any more message. So you can check if the message has 0 bytes. So you do, maybe you quit, maybe you close the connection. So whatever you want, because if you send data, the party will not reply. So you get, this is a nice way to check if the server doesn't want us to communicate anymore. And then also there is no end of transmission character on a socket. Like if you're sending some data, you really have to decide how how should someone know that something has finished. You have finished. You sent your message, or your message has already been sent. Like are you in the same like associated to that same message? Are you expecting some more message? So it's up to the server and the client to find some protocol to communicate, but the socket by default doesn't send any character to say that well, that message this is the end of the message. Normally they, for IRC, we send the carriage return and the new line, to at least for me on Windows, to specify that this has the communication has ended. So these are some nice tips. And then most people, when they talk of some beginning, something basic to do with servers, so they start with eco server, which normally they just bind to a port and an address. Like the server starts listening at that port and at that address. Normally, when we don't put anything, it will listen on your whole network, so other machines on the network can reach to it. Okay, so and then you listen for a maximum of 5 connections, and then you can you when a connection comes, you accept. Another connection, another client comes, you accept. And that's a bit how a somewhat basic server looks like. And then for connecting, same as the bot, you just connect and then you print what you receive. Okay, and here we are closing, but normally we should shut down before, but that's some basic, which is kind of really simple. So maybe if someone is a complete beginner, okay, and we had to explain to him like what a server is. Maybe it's like a waiter who listens to orders, to customer requests, and then when he has the request, so he sees what to do with it. Maybe if the customer orders maybe some food, he can propose some drink, or he can right away order the food. So a server, it's like that, basically just listening. And then you have some common types of servers, not web servers. I made a mistake here. But you have web servers, you have file servers, you have email servers. That is, they have different protocols on how to communicate, but at the base they are the same. And then concerning protocols, like you have IRC, we saw this is one protocol, and the server we were communicating to, that was an IRC server. And well, that's a fact from the from the docs. You don't want to every time have use the socket module. Like you don't have always to need to have a server and a client. So there is this utility that you can get the IP address of a web address. So that's it. And then normally even in Python, so normally you should put shutdown before close. So you are kind of warned. And then in many sockets coding, you will see with socket.socket, then these two lines. Normally, these two are actually integers normally. And then AFINet, normally it designates IPv4 addresses, and AFINet 6, it designates IPv6 addresses. And then the docs has an example of using AF and spec for both handling IPv4 and v6 addresses. So, and then socket.sock stream, what does that mean? It means that we are making a TCP connection diagram for UDP. So that's it. Normally, why they use the with here? Normally, in many socket programming, you will see with. So with what the advantage of using with is that it automatically closes the connection for you, shut down and close. So you don't need to write shut down and close, just like opening files. And sometimes you might see socket accepting 3 parameters. Well, that's in the docs. So don't be surprised if someone uses 3 parameters for socket. And normally in Python, normally here, they define it as keyword arguments. But normally in Python, if you define it as keyword arguments, so you can still use positional arguments. And then if you don't specify positional argument, we'll use the value in here. But that's just for info. And normally, if you move forward, one interesting project we can say of sockets programming, like, practically, because this server normally doesn't handle the echo server, does not handle multiple people at the same time. Okay. So this project that I put its link here, it's he kind of implemented it cleanly, but I don't know if he's the original author, because more or less you will see the same code over the internet. So you don't really know who copied on who, but for demonstration purposes, this was a nice piece of code. Okay, just like any server, it binds, it listens, and then on connection, it appends the connection to keep track, and then to deal with the client, it starts a new thread, and then if there are, and then if there are no connections, it just closes all connection, which is nice. Remove connection, well, that's how he does it. And then he has a broadcast function, which is just looping over the connections and then sending the message a client sent, the string here, something very, very simple. And then the function that was put in a thread, it's receiving a message from the client, and then just broadcasting it away. And then if there is an exception, so it removes the connection. So that's the most basic, clean, and most understandable code for a, like, that is the traditional approach to to a normal server, if you can say that is spinning a new thread for every connection. But nowadays you have many more methods. So, and then concerning the client, so it just connects, and then well, it just sends the messages and then handle message. It's like that. It's something very like it's clear by itself. So uh, and then if ever you want to just for this, if ever you want to see it in action, let me just oh, it's the bot is still running, which is kind of nice. Mm, okay, so let me just Malit is 4 chart. Okay, the server is running. So let us run the client. So you can send in something, and then here you will see. And if you add one more client, so you will see in here, and you will see in here. So it's something very simple that works, and the code is clean and understandable. And I think that one of the basic project you can do is a web server. Normally, this is the basic. What is different from a normal, server is just that normally this server won't work well if you post, if you do anything, because it does not handle anything. But normally, if you run this server and then you access it in your browser, it will work. Why? Because it's using it's using the HTTP protocol, and then normally when you make a request to it, that's the info that you get. That's the info that your browser sends. So I think that is another interesting project. But if ever you are doing some web requests, well, obviously you won't use something as low level as a socket programming. You just use the request library for get, etc. And then you might want to dig more into IPv4, IPv6, and normally these two approaches are used for instead of threads for servers. So, and since we were doing machine learning today, one of the thing I saw is that as Python programmers learn machine learning, so even with socket programming, so they add in machine learning. This is someone who has a repo where he has a phone app which he downloaded from the Play Store, which gives him the phone's location, the phone's orientation sensors data over UDP. And then he built a Python program and used machine learning to determine exactly in which position the phone is, and then use that to control his mouse to play Call of Duty. But it's interesting that when you know machine learning, so it gets somewhat interesting. So this was intended to be some practical starting point with circuits programming. So if someone has something to add, so feel free. Yes, something has something else to add.
I guess this might be handy, even though never dug that down, but might be handy when you do like some custom IoT stuff. Um, I remember I worked on many little IoT project with Arduinos and all. And it might come handy to send uh, and to create little um, well communication between like let's say a Raspberry Pi and an Arduino or stuff like this. But yeah, thanks for the presentation, Abdulrahman.
Okay, so thank you for coming, but if I were to choose a protocol for communication, the HTTP protocol is very nice because it's you have lots of support for it, and it's everywhere. It works well, and you even have a in Rust. There is someone who made an operating system, like I mean a viable operating system. I don't remember its name, but for the file system, it actually inspired from the from the web, and he was saying that the traditional Unix approach to file system is flawed. He was explaining how, and then he said that in the operating system that he was building in Rust, so everything is considered as a resource. But the web, in terms of protocol, as a protocol, is really great. Well, in implementing from scratch, maybe it's not very nice, but yes, it's a great protocol for sure. I think thank you very much, and thank you, uh, Mrs. Karina, for being the host. And yes, so I think we can finish the session.